12 o'clock, let's go ahead and get started. So welcome to today's presentation of the Dissertation Power Hour. And today is Thursday, April 27th, 2017. And we're going to go over all the wonderful things that Excel can do. MS Excel, Microsoft Excel spreadsheets. You will be surprised. Okay. And I am Richard Gardner, the Quantitative Learning Specialist. So the version of Excel that I will be using today is the 2016 version. It's the latest one. I'm pretty sure most of the older ones, I know 2013 has a lot of these same options, et cetera, et cetera. So let's go ahead and get started. And again, if you have any questions, go ahead and hold them to the end of the presentation. You can use your little Skype chat box there, but because I'm the only presenter, I won't be able to see these things. So we're going to start with descending and ascending order. Give me a second. Pull this bad boy up. So you have a bunch of data. I tend to use columns because you can see a lot more action on a column than you can on a row. But you notice these are not in order. They're not in cardinal order. And what you would do is you would simply highlight them all. There's a lot of them. And you would go up to sort. You can go smallest to largest. That's called ascending, or largest to smallest. That's called descending. So I'm just going to put them in from smallest to largest. Bam. And that also works with alphabetical order too. So you can use regular words if you get a lot of names or something. But that's the first one. That was pretty easy. Let's go ahead and move on to. I'm going to show you real quick how to transpose a row to a column. So a lot of data that you pull from either like a Microsoft Word, Microsoft Word document, they tend to put stuff in rows, data in rows, which makes it real hard to work with in Excel. So I'm going to show you how to change a row into a column or vice versa. Simply highlight your row. A lot of data here. And again, that's what Excel is good at, is handling large amounts of data. So highlight it all. Man, I might have gotten a smaller sample, but we'll see how far this thing goes. All right, this is ridiculous. Oh, there it is. Okay. Right click, copy. Pick any row you want, any cell. Right click, you're going to hit this paste special transpose. See that? So now you have a column that used to be a row. And now I want to put this in order too, so I'm simply going to go to put in smallest to largest. See how convenient that is? Imagine you try to do that by hand. It would take you years. All right. Next at bat, pie charts. So pie charts, you want to make it look nice, not too fancy, but nice. So pie charts in Excel are much nicer than what SPSS puts out. So let's say you have a bunch of data here. We're going to make a pie chart of ethnicity of people in a study. There's all the data. So it's real quick. You simply highlight the data first. You go to insert. Now, if you're not sure what type of chart, I would recommend go to the recommended charts. It basically pulls up all of them. So I could do a sideways bar chart, a vertical bar graph, but this is for these guys. So we're going to do there's the pie chart. You could change the title to ethnicity. You'll notice the colors are down here represented by who's what. But if you don't like this one, go up here to the top. You got all these different fancy versions. And from what I understand is you can go online and download a lot more free templates that don't cost anything. But now remember, your reader should be able to see what's going on real quick and easy. So like here's a good one. If you want it by percents, so ethnicity, 32% were white, 17% were African American, etc., etc. You don't like that, you could do it by, don't like that one. Don't like that one, don't like that one, don't like that one. I think there's a way you can put in the numbers if you really want the numbers. There's another one that I kind of like, but I'm going to stick with this one because it's kind of pretty to look at. All right, so that was a pie chart. Moving right along. So now let's do a bar graph. So here's all the cars, the different makes and models of the automobiles, and here's the frequency of those cars. So we're going to make a frequency of each car, and this kind of screams a bar chart. So we're going to go to Insert, Recommended Charts, again with the recommended charts, and here's a bar graph. I like that. Now you'll notice I forgot to copy the makes and models, so I'm going to get rid of this and do it the right way. So this time I'm going to highlight both of them. Go to Insert, and there it is right there. And to click on the title, you simply, to change the title, simply click on it and type in the new one. So we're going to be Cars by Make. One little sidebar. If you got too many names here in the columns and they're not showing up on your actual graph, if you click it and spread it out, they'll show up. It's quite a beautiful thing. So, but that's our bar graph. Please let me know if I'm going too fast, but these are pretty basic, but I use them all the time here. So what's next up on our list? Ah, yes. Measures of central tendency. So what they're talking about there is your means, your standard deviations, your modes, your ranges, any kind of regular statistical descriptive information that you're looking for. So let me go ahead and pull up a data sheet. So let's pretend you have a mountain of data for different cities. This is our example, different cities. And we need to find the following. We need the median, it's the one in the middle. Mean is the average. Variance and standard deviation for each one of these guys. Oh my goodness gracious. But now through the power of Excel, this will only take about 30 seconds. So we're going to pick a cell right next to median. I'm going to go to this little function bar up here. I'm going to click the function bar. I'm going to click the statistical category. Make sure you go in there. And we're going to scroll down to, you guessed it, median. Median. So it asks you, what do you want the median from? Don't ever trust the numbers that they put in there automatically. They're never right. I don't know why. But simply highlight your data. And hit enter. Bam. There's the median. Mean, you're going to do the same thing. Click the cell. Hit the F of X key up here. Make sure you're in statistical. And mean in Excel is average. Click average. And again, highlight your data. Never trust what it says in the given rows up there. Enter. There's the mean. Let's do the variance. Click the cell. Don't forget to click the cell first. Hit the F of X symbol and variance. We're going to pretend this is a sample variance. My advice is always pretend everything is a sample. So we want the variance. It starts with a V, doesn't it? Variance, right? Variant.s, S means sample. And again, highlight your data. And enter. There's the variance, right? That is the distance each one of these guys is from the group mean of 114 squared added up. That's the variance. Okay, last one, standard deviation. Go to the f of x. Make sure you're statistical. You're going to go to St. Dev. And again, pretend it's a sample. Highlight your numbers. Again, remind me next time to use smaller sample sizes. Hit enter. So if you take the square root of the variance, you're supposed to get the standard deviations. That's how they're related. But now watch, here's the beauty. You don't want to do these for every city. It'll take you forever. So what you're going to do is highlight all four. And in that little corner, that little square down in the bottom right-hand corner, move your cursor over until you get the plus sign, and then simply highlight it all the way across. And the software knows to switch columns, and you are done, son. So there's all the medians, means, standard deviations, and variances for all these cities. Wow, pretty amazing. All right, moving on up. Let's move to the dreaded histogram. Now, SPSS does histograms with a few reservations. I actually like the histograms by Excel a lot better because you have a lot more control over them. With the interval ranges on your x-axis, you don't have a lot of control in SPSS, but you can in Excel with some reservations. Okay, let's just highlight the data first. You can go to insert, you can go to recommended charts, histogram. If it doesn't show up, you go to all charts. Histogram is in the newer versions, but it won't allow you to switch the charts here. See that? That's not a histogram. It won't allow you to change the ranges here. Okay, so don't use this fashion. I'm going to show you a better fashion. First thing you're going to do is you're going to type in bin, B-I-N. Next. Sorry about that. All right, we're going to make the perfect histogram. Pick a cell, any cell, type in the word bin, B-I-N. I'll explain what it is later. Next one, type in frequency. That's gonna actually count how many items are in each interval. And let's go over one more box and call this interval. So a regular histogram should have anywhere between, I don't know, 5 to 10 different interval ranges. You don't want to have a whole bunch, right? You're just basically trying to group the data within specific ranges and count how many are in that range. Just, keep it as basic as possible. So let me make it pretty. So I'm asking for intervals from 1 to 20. Little trick. So I'm going to pick the interval, the box under interval. If you type in 1-20, you're going to get a date. Bam. You don't want a date. There's a way around that. So any number that might come out as a date, if you want to undo that date function, simply hit the apostrophe, right? The apostrophe, and then hit 1 through 20, and it disengages that date function. Okay, so there's the first interval. The second one, I want 21 through 40. The next one, I want 41 through 60. So my ranges are 20 units long, 61 through 80. Last but not least, it's 81 through my intervals. Your bins are the last number of the interval. So this first bin is 20, second bin is 40. And you'll notice once you have a pattern of more than 2 going, if you highlight both of them, you get that little box again. You simply hover your cursor over the box until it turns into a square, and it fills it out for you. Isn't that amazing? I am amazed. So what I'm going to do is I need boxes. I'm sorry, I'm old. I like boxes around my thing. So here comes the hard part. Frequency. See that? We're gonna tell Excel to count how many of these guys are between 1 and 20. And then how many of these guys are between 21 and 40, et cetera, et cetera. So here's the trick. You got to click and hold down and highlight all the cells to past one of the last one. I'll say it again. You need to click and highlight the cells underneath frequency to one past the last digit here. And then you go up here. You're in the function bar. You're going to type equal sign equal FREQ, and the frequency function should pop up. So go ahead and click on that. And you'll notice it's asking you, the first thing, it'll be bolded, data, the data array. What data do you want us to pull from? You highlight all the data. Don't forget your comma. And then your bin array. That's your bins right there. See those bins? This is where it gets a little bit weird. So you're going to hit Shift O to get the parentheses in there. And now you, at the same time, you're going to hit Shift Control Enter. Shift Control Enter. So in other words, there's 21 of these values that are between 1 and 20. There's 17 between 21, 14, et cetera, et cetera. So we're not quite done. So now what we're going to do is we're going to go ahead and turn this into a graph. Let's go ahead and highlight the frequencies. We're going to insert, I'm not sure which. Let's do this one. It's a bar chart, not really a histogram, but I'm going to show you how to change these values on the x-axis to these intervals. Okay, so you're going to click on them until you get the box around them. You're going to right click. You're going to select data. And so you're going to edit this side, right? You don't want 1, 2, 3, 4. You want 1 through 20, 21 through 40, et cetera, et cetera. So we're going to edit. And we're going to say, use this data for the x-axis. And be quick about it. Boom. Okay. So it's starting to look like a histogram, but I want my bars to be closer together. So what we're going to do is double click on one. That opens up this box over here. All you have to really do is just kind of change the gap width to, I don't like 0. It's too close. If there's zeros, it's kind of hard to see what's overlapping. So I always leave a little bit of overlap there. Now that, my friends, is a histogram. Okay. That's how you make a good looking histogram. So you'll notice it's not normal, period. Okay, so that was a histogram. That was kind of exciting. Let's keep going. Coming up next is how to do a paired t-test. So remember, a paired t-test is like a, there's only one group, but there's two measurements. So like think of pre and post. That's the most used way of a t-test here. So give me a second here. Okay. So that's not paired t-test. Hold on. There's a paired t-test data. So I want to see if there was an improvement over the post-test from a pre-test. Okay, pretty basic. So what you're going to do is, there's several ways to do this. You can do this going by the f of x. Make sure you're statistical. You can go to t-test right there. Click OK. You can highlight the data sets. There's array 1. Click your cursor in array 2. Drag array 2. Tails. If I'm assuming one outcome is going to be greater than or less than, that makes it a one-tail test. And the type is, it's a paired t-test. So that would make it another 1. But that number right there, that is just that's the probability that the null is true. That's just the p-value or the sig value. It doesn't give you any other information. So there is a significant difference. But let me show you the golden way. All right, so what you're going to do is you're going to go to data. And this data analysis, if it does not show up, I'll say this again, if this data analysis does not show up on your data bar, you go to File, options, add-ins. Give it a second. Add-ins, there it is. You're going to click Analysis Tool Pack, and then you're going to click Go. Don't hit OK, hit Go, and it'll add it in there for you. Okay. So we're going to go ahead and go to Data, Data Analysis. Scroll down to the t-test. This is a paired two-sample t-test. Click OK. So variable range 1 is our pre. Click in the box for variable range 2. I like that. And this tells you where do you want the output. If you don't mark it, it puts it on a new page. But I like my output right next to my data. So I'm going to put it right around G5. Click OK. Okay. So there's your paired t-test output. Ta-da. So here's the mean of the pre-test, mean of the post-test. There's the variance. So the variance right off the bat, it's obvious you did not violate the assumption of homogeneity variance. They're practically the same number. How many in each group? Don't care about the correlation at this time. The degrees of freedom is 16. There's your test statistic, right? Negative 2.23. So this, because we expected one to be better than the other, this makes it a one-tailed p-value. And that's your answer right there, right? So you reject the null and say, yeah, there was a significant difference between the means of the pre and the post, and it looks like there was significant improvement in the post-test over the pre-test. That was kind of fun. All right, that was pretty easy for a t-test. Let's do the independent t-test. The independent t-test is when somebody who is in one group is not in the other group, okay? But there's only one measurement, so the DV here is one measurement. But the IV is the different groups, right? So whoever's in the left-handed group is not in the right-handed group. So pick a cell, any cell. You're going to go to Data, Data Analysis. It is a t-test, two-sample, assuming equal variance. We're going to check that out. Remember, the assumptions of any t-test is normality of the data, which we're not checking, independence of observation, which you cannot check, you just assume has not been violated. And the third one is you look at the variances between the individual groups. They should be relatively the same, okay? So click OK. So our first range is our lefties. Our next is our righties. And again, the output range, I want it where I can see it. Ta-da. So there is a independent t-test. Very nice. So let's look at the variances now. So 9 and 10. Okay, did not violate the homogeneity variance. So you got 12 in each group. This is the hypothesized mean. Remember, the hypothesis, the null hypothesis states that the means are equal. And if they were equal, you subtracted one from the other, you would get 0 as a difference. So that's what this one's saying. So, and since we didn't know who was going to be smaller or larger, we didn't choose sides on who was going to be the biggest here. That would make it a two-tailed test. And there's your significance, p.18, so you would not reject a null. In other words, you did not prove that there was a significant difference between right-handed and left-handed people in terms of production, whatever these things were, okay? Moving on. We're down to the dreaded one sample t-test. Now, I just discovered this recently myself. Excel doesn't have one sample t-test in its repertoire here, okay? It's not one of your options. But I figured something out. So what I'm going to do is I'm going to show you how to do a one sample t-test in Excel. You're going to put everything in a single column. Okay, there's the first, and here's the second. Okay, so I got everything in a single column. Now, the stated mean that you're testing it against is 18. So you simply make a column of 18s. So we're gonna trick Excel, and we're gonna run a paired t-test using these two as the pairs. Okay, so and you get the same results. So let's pick cell and Excel. Go to data analysis, paired sample, and again. So here's your. Hold on. Make sure you're at your cursor where it's supposed to be. And again, I want it right where I can see it. That should be fine. Click OK. Bam. So there's our paired t-test. Actually, it's a one sample t-test. My bad. And this says that there was a significant difference. Okay. So we're assuming it's either a one tail or a two tail. It doesn't really make a difference because look how small the p-values. They're both significant. So in other words, the mean of this individual group up here is significantly less than the stated mean of 18, right? So the stated mean was 18. That's what we call a claim or a population mean, something like that. So that's how you do a one sample t-test in Excel. Hope I'm not boring you out there, because it gets better. We can do a one-way ANOVA in Excel. I did not know that. So we're going to run a one-way ANOVA to see if there's a significant difference in, let's call these stress scores, between the three different treatment types. First group gets biofeedback. These guys get, what is it, comprehensive behavioral therapy something, and the last guys get yoga. So let's run a one-way ANOVA to see if there's a significant difference between the means between biofeedback, CBT, and yoga. So we're going to go to data again, data analysis, and ANOVA single factor. That's us. Certainly is. So the input range, you highlight just all your columns. This is the cool part. Because you got three columns, Excel knows you got three variables. Isn't that amazing? I am amazed. Okay, so output range. Again, I want it where I can see it. I'm just going to put H5 this time to mix it up a little bit. Bam. Okay. So here's everything you need to know. You can even look at homogeneity variance. So this first one is biofeedback. Second one is CBT. The third one is yoga. Now here, I'm going to use this little trick. I'm going to highlight these, copy, and I'll just go here, paste, transpose. So I don't have to guess. I can actually see them. Isn't that nice? Okay. So who had the highest average? Yoga. Who had the lowest? Biofeedback. Was there a significant difference there? Yes, there was. P-value is much less than 0.05. Therefore, there is a significant difference between the stress scores, whatever they were, okay? With the highest seeming being yoga and biofeedback being the best at reducing. Now the variances, they're supposed to be similar, but I think a rule of thumb is if one is 10 times greater than the other, then you're going to violate for sure. I believe that's called the F-max rule, or it's close to that. So if you divide the biggest variance by the smallest variance, and if that number is greater than 10, then you're going to violate the assumption of homogeneity variance, and you probably should not use an ANOVA. Okay, but that's how you run an ANOVA, a regular, a simple one-way between group ANOVA. There are other ANOVAs that I have not investigated yet, but let's keep pressing on, shall we? Scatter plots. You're going to do a lot of scatter plots, okay? Everybody does a lot of scatter plots. You're going to get these correlations to see if they're related or something. So to put a scatter plot in there, simply highlight the data, just the data. You're going to go to Insert. And again, if you're not sure, click on Recommend All Charts, and usually the right one pops up. Click OK. And what do? You have a scatter plot. Now let's redo this, but this time we're going to put in a line of a best fit line. This one's going to be a line of least squares regression. That's the most popular one. Okay. So same thing. You highlight the data, just the data. And insert. I just got an error message, so I don't know if this thing is recording or not. So, dang it. Is anybody out there? Can anybody hear me? Let me finish this first and I'll come back to you. So insert, same thing. We're going to do the regular dot, scatter plot. Here's the cool thing. Hover your cursor over any dot, right click. You're going to add a trend line, and it shows up over on this side. We're going to put the display equation on the chart and the R squared. The R squared is like the power of your relationship there. So according to this, we got an R squared of 0.01, which is weak. So in other words, this prediction line isn't a very strong prediction line, but there's the actual equation. Okay, so there's the equation. All right, so I'm gonna have to hold real quick. I got an error message on my computer. I'm not sure anybody's hearing this. So let me bug out here for a second. Okay, so what should I do? I should probably just stop the presentation. Stop. All right, sorry about that. I had to edit out. I had some technical difficulties. The computer said that nothing was being recorded, so I had to fix that. So, but moving on. So now let's do some correlations in Excel. So here's the data. Let me realign all this stuff up here. So here's the data. We want to see if there's any kind of correlations going on between English scores, math scores, physics scores, history, and chemistry. I would think that people that are good at math are also good at physics and chemistry. Not always the truth, but that's usually what happens. And maybe English majors and history majors are highly correlated. Don't know, but let's check it out. So we're going to go to data. We're going to scroll all the way down over here to data analysis. Oh, no. Oh, you can see it here, can't we? So we're going to go to data. We're going to go to data. Data analysis. I'm going to scroll down to correlations. And again, the input range is easy. You just highlight the data. And again, the software recognizes what's what. And I want to put it where I can see it. So let's put it on, I don't know, J6 maybe. And there's my correlation table. Let's get rid of this guy. So, and again, I can't tell which is which, so I'm going to go ahead and copy, paste, right? That just tells me which is which. I'm going to copy again, copy, and then right-click, paste, transpose, so I know who we're talking about here. So, So chemistry and English, not strongly correlated. Chemistry and math, very strongly correlated. Chemistry and physics, very strongly correlated. Chemistry and history, negatively correlated. So if somebody's good at history, they tend not to be good at chemistry. That's what this data is telling us. And same with math. People that are good at math are not very good at English, and vice versa. English and physics, not very strong, but they are positive. Physics and math, that's the strongest right there. So people that are good at math, they should be good at physics, et cetera, et cetera. But that's how you do a correlation table in Excel. All right, last thing I'm going to show you in Excel is that you can do multiple regressions in Excel. I know, who knew, man? It's really cool. So let's go to our multiple regression page. So I'm going to try to show you how to do this. We're going to use the predictor variables of age, income, blood sugar levels, and try to predict their DV, the criterion of how many days we can expect them to stay in the hospital. Got it? So predictor 1 is age, predictor 2 is annual income, predictor 3 is their blood sugar levels, and their DV, the criterion or outcome, is the days in the hospital. So it's actually going to go quite fast. You're going to go to data. You're going to go to data analysis. You're going to go to regression. Okay. So careful. So the Y range is your DV, right? So that's our Y range. Just highlight our Y data. Our input range is all our variables. And I'm going to put it right where I want to see it. And it's going to be right around G5. And there's all your output data for your multiple regression model. Isn't it amazing? Let me just run this through you for you. Run this by you. Or whatever. You know what I mean. Hold on a second. So these are our, right? This is age. I can't remember. This is, okay, age, income, blood sugar levels. And it tells you if they're significant or not, okay? So never look at the intercept. That's just checking it against 0. But age is a significant predictor of hospital stays, as is how much money they make, right? It's a significant. It's the p-value is less than 0.05. And the last one is, too, their blood sugar levels. So they're all 3 significant predictors. It gives you your R squared, right there, R squared, 0.71. In other words, your model is really, really, really strong, really good at predicting. And it is a significant model. There's your significance right there. But, okay, that's it. I just wanted to show you all the important things. Okay, so that's it for multiple regression. Any questions and comments, don't hesitate to email me, rgardner@alliant.edu. I just wanted to show you all the important things that Excel could do if you can't get a hold of SPSS. So I want to thank you. And everything we've done today, like always, the dissertations will be recorded, edited, and put up on the Hawk 5. That's your dissertation toolbox Moodle. Go to Moodle, go down to the very bottom of the search box, type in Hawk. It'll show up, click on it, it is self-enrolling. That's it. MGZ.